and let me just welcome everyone. So this is the RFCs we love. We have an RFCs we love dedicated to IPv6 PDMV2. This is our 23rd RFCs we love, and the 10th one since the world went into the pandemic situation, and instead of meeting physically, we have been doing this virtually. And this is organized by IIESoc, which stands for India Internet Engineering Society. We are an organization which does events like these, as well as annual event called Connections, which we have been doing since 2017, physically in Bangalore, in Kolkata, and for last year we did it virtually. And we are planning and hoping that we are able to pull it off this year as well. Apart from that, we did a very successful IPv6 webinar series, which was done in collaboration with INTC. We plan to continue this. So we have applied for a grant, and we are waiting to hear more from APNIC and ICIF Asia, and hopefully the webinar series can continue and we can bring in a lot more interesting topics to you guys. Let's do a quick poll. Let me launch it. Good way to figure out like how many people who are joining for the very first time or who have been coming to RFCs we love and connections for a long time. So it will be a good idea to, if you can click the poll. There are some new folks. It's always amazing to see new people joining in every time. So this is excellent. I'll leave the poll open so that people can continue to put in for a while, but it's good to see new people joining our event. So thank you, welcome. Some news, IETF 112 is online. It's on 8th to 12th November. The fee waiver is available. This time it is much more favorable time to India compared to last time, where we were like, we got the brunt of the worst timing, starting at midnight and ending at 6 in the morning. But this time it's much more favorable. So I hope more people can join in. We are at the early stage of discussing our annual event called Connections. So we would require more volunteers. So if people who are looking to help us in running this event or have some suggestions, please volunteer, please help out. I will put in way to contact us in the chat once I've stopped talking. If you are new to IETF and you need help, we did a webinar last year. This is a link. I will put that link as well in the chat later. And that has all very nice presentations on how to start participation, and all are well applicable, even 1 year since we have been in pandemic, and more so now, like some of the tips that we gave could be useful. And I think we have some new timers who will be presenting in this call. So it will be good, to get their feedback as well, like what helped, how did they start participating in IETF. So I'm looking forward to hearing from Ameya and Abhishek as well on that. So we talked about IPv6 webinar. So all the webinar series and slides and lab sessions, everything is available online. So if you missed it and if you are interested in IPv6, this is the resource link that you should go to, iiesoc.in/IPv6, and you will find a lot of good webinar and other materials here. And hopefully we can continue to do this work in the future as well. This work was done with the support of APNIC and INTC. So I would like to thank them. We have found very good partners here. So I hope this partnership can continue for a long time. This is how you stay connected. We have our IETF has helped us host a mailing list. We have a direct email, and of course there is a very active WhatsApp channel. So that's the most place where most of the communication happens. We also are on LinkedIn and Facebook. As I said earlier, I'll post all of this in the chat, so don't worry about not able to remember the mailing list name, etc. I'll put that in the chat. Okay, so let's start with the RFCs we love. We had a bit of a break in between. We could not run events. Some of us got a little bit busy, but we are happy to bring RFCs we love back, this time focusing on IPv6 PDMV2. Again, a very timely topic, which they had a side meeting in the last IETF as well. This brings in a very excellent group of people from industry, from academia, from undergrad, from PhD, from professors. So I think I'm looking forward to how a group of people have come together and produced this piece of work, and looking forward to seeing the progress of this work in the IETF as well. So we would have a very quick introduction, then an overview from Ameya. We'll talk about enterprise point of view, where Mike would bring in his unique perspective. We have Tommaso and Adnan talking about crypto, and then the real implementation, the implementation work that's been done. So PDMV2 implementation. So looking forward to knowing about that as well. So let me give a very quick introduction to the team, and then I'll pass it on to Nalini to run the rest of the session. Nalini, unless you are new to IIESoc, I think you would have known Nalini. She's the president of INTC. She's the CEO and founder of Inside Product. She is amazing. And it's been a pleasure working with her all these years. Her experience in network performance analysis, measurement, monitoring, troubleshooting, and even training to Fortune 1000 companies and even US government has been legendary. And we have been lucky to have her as part of our IPv6 webinar and other series as well. She has been the advisory board member of IIESoc from the start. So we have been very grateful for her guidance from the very start. We have Ameya. Ameya is an undergrad CS student of NITK Surathkal. He has been involved from PDMV2 from the very inception. So it's looking forward to his point of view and how it was as a student taking part in these activities. So I'm looking forward to hearing from him as well. We have Mike, who is the lead network engineer, and he brings in real enterprise experience, managing enterprise-wide networks and diagnosing and measuring those networks. He's a member of INTC, and we are looking forward to have him speak from the enterprise point of view. We have Tommaso, who is from University of Florence. He is from professor in the Department of Information Engineering. He has done some amazing work. He has won Best Paper Awards. He has 90 publications in various different areas like IoT, network security, and now in this crypto world as well. We have Adnan, who is a PhD research scholar at the Department of Information Engineering in University of Florence. He's active in security, IoT, SDN, and fog networks. He has been involved in IETF as well as in open source NS3 simulator and 6LoWPAN ND protocol. So it's a very good mix of people that we have. And finally, Abhishek Kumar, who is also from NIT Surathkal. He has recently joined the team, and we are looking forward to hearing his experience as well. And finally, let's kick off the main meetup. Please use the Q&A to type in your question. If you would like to speak, that's completely fine. Just use the raise hand feature, and then we could give you mic access so that you can ask your question orally. So either is fine. Please, let's have a good Q&A session as well. And I'll give it off to Nalini and let Nalini run the meeting. And I would like to thank everyone for attending, and let's have a good meetup. So I'm going to stop sharing and pass it on to you, Nalini.
Hi, everybody. Let me get my screen sharing. I hope you can all hear me okay. Drew, thanks so much for the great introduction. It's a real pleasure working with you and seeing the growth of IIESoc over the years. As Drew said, we have a very good collaborative team. Because we need it, we need industry perspective, we need the cryptographic perspective, and then we need folks who can actually implement. That's where the rubber meets the road, right? If you can't implement, and you really, you're just, that's the best way to me to write an internet draft or a protocol, is to see it live. So let me set the stage and then get out of the way, and so everybody else can talk. So basically, we have PDM, Performance and Diagnostic Metrics for IPv6 in 8250. The whole idea of that is that we need to have embedded performance and diagnostic metrics in the packet itself, and that's where it belongs. And in our viewpoint, it belongs at the IP layer. Having said that, we want to be very, very careful that the data cannot be misused. And you know, as I say, PDM is wonderful, but I have to say that was one of my hesitations with trying to push out a wide implementation of the original PDM. There's the real potential for misuse, and so we need to have encryption. But remember, this is at the IP layer. It's at the IP layer, and so whatever you do, it's got to be very, very fast. You can take some time during setup, but during normal data traffic, it has to be fast. It has to be scalable, and that's where Tommaso and Adnan have been just invaluable to us. And then Mike will tell you too what our requirements are within the enterprise. So again, that's where the rubber meets the road. You can design whatever you want, but if you can't use it in real operation, what have you exactly done? So our hope is that as we progress, then maybe our methodology can be used by other IPv6 extension headers. Let's just see. Let's walk. I mean, let's get some going. Let's walk before we run. And so then, you know, as we go forward, if it works, heck, you know, let's see what else we can do. So now I'm gonna stop talking, and Ameya, please go ahead.
Yeah, thanks, Nalini. I'll be giving an overview on PDMV2, explaining how it works, compare it with original PDM, and talk about the new features added in PDMV2. Next slide, please. PDMV2 tries to address some of the limitations of PDM in terms of security. It adds confidentiality and integrity to its data. Confidentiality means the data is encrypted and is hidden from the network in between. And integrity means the data has its integrity and isn't tampered with. PDMV2 provides two options, encrypted as well as unencrypted. We have kept the unencrypted option in case someone or some organization wants to use PDMV2 over VPN, internal network, or any network which they consider as secure. For encrypted flow, PDMV2 consists of registration phase and data transfer. So the registration phase consists of secret negotiation. So how will this negotiation take place, and how will it take place for large enterprises? So these are some of the questions we'll be answering in the upcoming sections. The registration phase is one-time process done before PDM data transfer. After that, PDM data transfer will consist of encryption, decryption, and occasional KDF, key derivation function. We'll be discussing more on this. For unencrypted flows, it's similar to PDM. Next slide, please. So for PDM to non-PDM machines, this is one of the cases we are also covering. For unencrypted flows, PDMV2 gives information on packet sequence numbers and global pointer. This is a new metric we have added, and we'll be discussing it more. PDM also gives information on server delay and round trip delays, but in this case, there are no delta times or these times provided, because if the receiver machine is non-PDM, we won't receive the packet sequence number last received. So, but anyway, we get the packet sequence numbers and global pointer. In encrypted flows, the data cannot be decrypted by non-PDM machine, but the data remains the same as the above. This data can be sniffed and decrypted later in time. Next slide, please. How to use it? PDMV2 can be used from a few minutes to a few hours. The users can mention whether they want to use it encrypted or unencrypted. If they choose to use it encrypted, then the registration phase should be already completed. To use and to enable PDMV2, there can be either a kernel parameter or we can write a kernel module. This is based on the implementation we write. The implementation we are working on is currently in progress and will be discussed later in the upcoming sections. Next slide, please. Here we have PDM packet layout and PDMV2 packet layout, the unencrypted one. So you can observe that there are some differences over here, like the version number is there. Then we have the reserved bits. We also have random number. Then there is a flip bit and the global pointer. There are these 5 new additions in the packet header. When we are encrypting this packet, this section essentially is encrypted in the encrypted version. So we'll look into these different newly added header fields. Next slide, please. Global pointer. It is a new metric added in PDMV2 to measure the amount of traffic sent from PDM node. PDM itself gives information on server delay, round trip delay, and correlation of flow packets. In addition, now global pointer will also give the amount of traffic sent, amount of IPv6 traffic sent from PDM node. Global pointers are based on the source address type, link local and global unicast addresses. Then there are random number and flip bit. These two fields are security related fields. Random number is the nonce in HPKE AEAD, and flip bit is used to indicate the change in session temporary key. These things will be discussed again in the upcoming sections. Version number is to indicate the version of PDM, and reserve bits are for future use. That's it from my side. Back to you, Nalini.
Thanks so much, Ameya. So now Mike will talk about the topology and why we have chosen to do things the way that we have. So Mike, let me turn this over to you.
Thanks, Nalini, and thank you, Ameya, for that great overview. And I'm the troublesome one on the team that just says, this is great information, I need it really bad, but it's going to be too hard or too complicated or cause too much overhead at enterprises and elsewhere, and we got to make it easy to do and very non-impactful on our environment. So the team has come up with some wonderful ways to do that, and I'm going to share that with you now. Okay. So let's just talk a little bit about enterprises in general. We do think that this is going to be great information to have. It's going to be accurate and immediately usable, and it's just going to be great to have to manage our networks. Is this, in my world, we call it PHI or critical or needed to be protected information. Maybe, maybe not, and it may depend on the session path. For instance, as I say here, that on the open internet, you may want to use that. On your internal connections, you may not want to. And then there's situations that are sort of in between, such as where you're using private networks and trusted partners and VPNs, may or may want not to use it there. So we want to be able to turn this on and off and use it where it's appropriate. And now to the core of what my issues really were with this is we want to make it easy to use, have low impact and low overhead. And so the big question becomes, how best can this be accomplished? So next slide, please. So the team came up with a couple different scenarios, and basically it involves, if we can just stare at this messy diagram for a couple minutes, you have clients on one side, you have servers on the other side, and then serving the clients, you have a primary writer, and that will manage the keys for the clients. So this is all pretty much about key management and getting things to the various entities so they can be decrypted. We have several different paths here down at the bottom. We're really entertaining looking at the primary client talking to the primary client writer talking to the primary server writer. Those are the two new entities. What is not new is that we still have, you know, our clients and our servers that are out there today. It's just that these new entities are going to help manage the keys and set up the decryption for those entities. So other sections of this presentation will go into more detail on how that happens, but that's kind of the overview that we want. And let's go into another couple slides and see why that might be necessary and why that might be helpful. So most of our enterprises and most organizations in general, we have lots and lots of servers, and we have many, many clients, and they're sometimes in multiple locations. And to manage an environment like that might be pretty complicated, and it might cause a lot of overhead and impact to your client and server base. And a lot of times you don't have the management capability in place to do that. So if every client that you have that wants to participate and benefit from the great information of PDM needs to keep track of these keys, that's a new and possibly relatively complex, and I don't want to call it high overhead, but there's going to be overhead and complexity involved there, and we want to avoid that or minimize that if at all possible. So let's go on to another couple slides and see why that exists and why and how best we can possibly deal with that. So we'll start with a ridiculous example, of course, which is, you know, you have one client, one server. That's nobody's situation more than likely, but you know, it will serve to illustrate the point, and we will build on that. So the client has the private key, the server has the public or the private key, and so that's not so bad of a situation. It's something that we deal with today. Even that sometimes causes issues, but that's probably pretty manageable. But again, serves to illustrate the point. We need to do this decryption. We need to have the keys in place to do that. So let's go on to to the next slide. So let's say now we have multiple clients and we just have one server. Again, it's not a terribly realistic example, but it starts to build the point that now we have all these private keys out there on the different clients, and the servers need to keep track of that. And it starts to get a little bit more complex. So as the network manager at an enterprise, you're thinking, well, okay, now how am I going to do this? I kind of do that today, but it's just adding to my woes. So I'm starting to see a little problem here. I still want that great PDM data, but you know, is there any way that I can have this be a little bit easier for me to manage? So let's go on to the next slide, and we'll introduce the primary client, which again, as back to the real complicated first slide, depicting all the flows, that's the thing that's managing all the clients. So now the server just needs to talk to the primary client who's managing the keys for all the server, and it just got a lot simpler for the server side. Okay, let's go on to the next slide. And now let's have a more realistic example. So now we have lots of clients and we have multiple servers, and we've got keys all over the place. So we still have that primary client in place, managing all the keys for all the clients. So the servers are talking to the primary client, kind of have a good idea where all the primary client keys are. And so that's okay. But what about for the client side? Now, how are we going to manage all the server keys? And so we want to do something for that side as well. So could we do something on the server side? Could we add a master server or a primary server writer? Let's go on to the next slide and see how that would look. And yes, indeed. And what a much prettier picture this is. Excuse me. And so now you've got the primary client, which is managing all the keys for the clients, and you've got the primary server and managing for the server side, and you've got the primary server and the primary client talking to each other. And this goes back to that new session that was on the first messy slide. And now this seems to be more of a manageable situation for enterprises and anybody else that wants to implement PDM. And I think we have one more slide that kind of wraps that up. And no, we don't. But so back it up just a second. And I just want to say that what's really cool to me to think about this infrastructure is, okay, now I can get my PDM information. Something's kind of helping me manage the keys, which was my biggest concern about putting this in. That also takes care of a lot of the utilization and resource consumption issues that I may have, especially on clients, which in some cases aren't too powerful and aren't managed really well. And then we have other things that may be coming down the pipe, or maybe coming in, or maybe here today where I need some help managing keys and decryption. So this infrastructure could be used for things beyond PDM, and that gets me really excited. So I think this is well thought out, and this will help us, us folks that are really concerned about implementing this and the type of impact it'll have on our network. So looks good, and I'll pause and go on and let us go on to the next section of slides. I don't think we're taking questions at this point, but please put questions in the chat at any time. Thank you. Back to you, Nalini.
Thanks so much, Mike. It's, as I say, it's so good to have, you know, to be taking real topology and implementation things into consideration as we go in, because then you can think about it from the very start. So now we'll have Adnan talk about the actual cryptography itself. So Adnan?
Hi, everyone. Can you hear me?
Yes, okay. We hear you fine.
As for we have published the first draft, and it is clearly stated that the RFC about the PDM, the first RFC, it is communicating with the clear text. So if we think about the attacker, so it can attacker can start the passive attacks or active attacks by getting the PDM data, and through the active attacks, the attackers can launch various type of attacks on the network, enterprise networks. So as you know that the PDM fields are very good for the network management and getting the knowledge from the network. So these fields must be encrypted, so we can save the internal data of the enterprise and how the nodes are working. So we have to secure this data. So that's the main task of the PDM version 2, to be secure, along with the global pointer, as Amaya told you. And next slide, please. So for this reason, we considered the basic security requirements, which are the confidentiality and the integrity. For both of them, we need the encryption algorithm and the hash algorithms. Next slide, please. So we adopted the current work by the
IETF.
no, it's not IETF, it's
IBPM. No, sorry.
I just forget the name of the group. They are working on HPKE, and it's a hybrid key, a hybrid public key encryption. So we just tailored, or we can say, I can say that we just apply the application of HPKE on the PDM. So why we adopt the PDM, basically HPKE, because it's more robust, it gives the flexibility to the network administrator, and because of the selection of the keys length, and there are various things that we can find in the draft. So basically HPKE, how it's different from the traditional one, because it gives you the symmetric key as well as the encapsulation, which is done by the public key. So it includes three well-known algorithms like KDF, key derivation function, CAM, which is the key encapsulation mechanism, and AEAD, which is the authenticated encryption with associated data. So it is robust than the traditional one, and it is significantly more efficient than traditional one that we are experimenting these days, and we have seen their latest draft, what they are doing on it. Next slide, please. So as you can see, HPKE framework includes the KDF, CAM, and AEAD. So these are the different values that a network administrator can select and use it for the selection of the secret or the length of the key, and what kind of the hashing algorithms they can use. So it's very flexible for that. And as you can see, AEAD also used by the Google, which is the Chachapoli protocol, the RFC 51116, if I'm not wrong. No, it's 8439. So this is the basic framework of the three protocols. So this allows a network administrator to choose what kind of hashing algorithms or key length that he can use. Next slide, please. So according to the our requirements and the use case of these three variants of HPKE, the key encapsulation algorithm, key encapsulation mechanism, it is used only for the registration phase between the primary writer and the primary server. And this algorithm will be used at once for the sharing of the symmetric key. And KDF function in the present work that we are doing, in this, the master key, the symmetric key, main master key, was shared between the clients, the secondary clients and the secondary servers. But it was questioned that we have to secure the master key by sharing among the clients, and the secondary clients and secondary servers is not secure. So right now we are working on it. But in initial phase, the first route, so we use KDF once in a while during the whole setup. And of course, the AEAD will be used for each single packet that transmit from the client side to server side and vice versa. Next slide, please. So this is the key encapsulation mechanism. And here you can see the receiver public key is used, and the sender symmetric key. By the way, I just want to tell you they have 4 modes, and I use the authenticated mode here. I'm presenting the authenticated. The rest 3 modes are in the draft, and so it is used to, the receiver public key is used to encapsulate, and this is the difference between the traditional one. Traditional one just gives you the encrypted symmetric key, but here is encapsulation, ENC, and symmetric key keeps stay on the sender side, and the encapsulation part to the receiver side, where the receiver use its own private key to get the symmetric key. So next slide, please. Okay, this is the key derivation function, the basic RFC that the current work they also adopted from the 5869. So we use when the key have to be refreshed. As Amaya told you that there is one bit we explicitly telling that when the key has to move or change. So it is used for the each session key. So typically this algorithm will be called like when the 2^15 value is completed. So in this there are different, sorry.
No, go ahead.
Okay. So in this, the basic definition is we have one symmetric key, which is in our case is a master key, and we are creating multiple session keys from them, and these session keys used for the communication, data communication between servers and the nodes, the clients. Next slide, please. So this one is the protocol that is used for each packet, and in this we have a like seal function. This protocol also a standard, which is the RFC 5116. So is a seal function to seal the packet along with the different inputs. Like here is the, you can see the K is the master key, but here the K will be the session key, temporary session key, which will be wrap around after 2^15. So on the receiver end, the open function is used, and the inputs are also same required. And we are still in the discussion for the second draft of the future work, that how to arrange these inputs and known by the both ends. Next slide, please. So HPKE in the PDM version 2 point of view, so we have a registration phase where our CAM protocol will work, and it is used for the shared master key. And then the online phase, like we are using the KDF function, and it helps for the clients to create session keys. And the nouns that we are using here, as I told you, there is a random sequence number, pseudo random sequence number, and we are calling them as a nouns because it's written in the standard that the nouns can be a sequence number or anything that helps that behave like a random number. Or so this thing is also in discussion, that runtime generation or pre-generation. And the third phase is online phase, where we are using the AEAD for the encryption and decryption purpose. Next slide, please. Okay, thank you so much.
Thank you so much, Adnan. As I said, this is really the heart of what we're doing in PDMV2. Is without Tommaso, Adnan, we could not have done PDMV2. So as I say, you guys are the heart of what we're doing, and we really appreciate all your work in this. We have some excellent input from the original IETF, the side session that we did. We've done some rework, and we'll be putting out a new draft. We're also, because AMEA Abhishek cannot implement without having the master and, the primary writer, primary server protocol being defined. So we're working on that, and we have another member joining the team who's helping us with that. And so you'll be seeing from him. But let's talk about implementation, because what we want to do is, again, just as you can't, you have to have the crypto correct. You have to have the topology correct. You have to have the implementation correct, because then you find out, actually you can have the greatest ideas in the world, but you can't actually do it. And so this is when you have to have running code. And so Abhishek, why don't you tell us about where we are in this?
Thanks, Nalini. Could you move on to the next slide? Hello. Hello, am I audible?
Abhishek,
Hello.
Can you unmute?
Yeah, Abhishek, you are audible, but it's slightly less. Your voice is less.
Is it better now?
Yeah, I can.
Yes.
All right.
Little bit, or maybe can you make it more louder?
Sure. No. Hello.
Yeah, this is good.
Okay.
Yeah.
Could you move on to the next slide? Okay. So when we talk about PDMV2, I see the project as having 3 big milestones. So first is PDMV1, which adds and processes the headers. So this is already done. Then we can use HPKE to encrypt and decrypt those headers. And finally, we have the registration phase, which solves the problem of scaling it up to the enterprise levels of key management. So out of this, we have completed PDMV1, and right now we are working on using HPKE to encrypt and decrypt headers. Could you move on to the next slide? Great. So before we move on, before we talk about where we are right now, I want to give you some background about kernel and user processes. And I have an example of a browser here. So imagine your browser. So in normal usage, a browser creates a TCP socket, it connects to the server, and it sends data. Now all of this at some level translate to system calls. And that is where the kernel comes in. So all system calls are part of the kernel space. And kernel space handles the low-level details of TCP connection. And this is where we add our PDM headers. So PDM headers are not added as a part of user space, it's added as a part of kernel space. On the other hand, on servers end, right, again, the kernel space processes the headers, and the server actually has no idea of whether you're using PDM or not. Next slide. Now, this is important because when we talk about implementing HPKE, we think, should encryption, decryption take place in the user space or the kernel space? And there are good reasons for both of them. And this is a problem that we're thinking about. Currently, we're thinking about the following problems. So if it is possible to call a user space function from the kernel, then HPKE can be in user space and PDM can be in kernel space. If we can add PDM headers to the user space, then both HPKE and PDM can be in user space. Or else we can rewrite the existing implementations to use crypto, which is the kernel's cryptographic API. So both PDM and HPKE will be in kernel space. Now, of all these options, there are trade-offs between the development time, performance, and the complexity. And this is where we are investigating the different options that we can take. What are the trade-offs there? All right, so there's in somewhat of an exploratory phase. Once we decide on which is the best approach to take, given our constraints, we can move ahead. So this is where we are in terms of implementing PDMV2. Next slide, please.
Oh, thanks so much, guys. Yeah, no, it's really been wonderful working with AMEA Abhishek on all of this. So now I think it's really important if if AMEA Abhishek can talk about how it's been working with the team, and even as undergraduate, becoming part of the IETF and writing a draft and so forth. So guys, please go ahead.
Yeah, hi everyone again. My experience has been amazing so far, and I've learned a lot. I started working with Nalini and Mike around 10 months back on PDMV1 implementation. I'm grateful to Mohit sir for bringing such opportunities to college and giving me the chance to work on it. Nalini and Mike wanted to make this implementation open source. So we used to have conversations on the implementation, and we also started our discussions on the security of PDM. And from that, we started our conversations on adding encryption to PDM. So my implementation work got converted into the internet draft work, the whole package. And Nalini and Mike offered me to co-author this draft, and I'm really grateful for that. Then Tommaso, Adnan, Abhishek, Rob, all of us joined, and now we have a team of, we have an international team with whom I get a chance to work. We have weekly interactions, and that is one of the best parts which I like. Then writing an internet draft, again, I was writing and maintaining the internet draft. So I learned about different tools and how to write an internet draft, how to submit an internet draft. So this has been really valuable. Then working on implementation, I started working for the implementation itself for PDM version 1. And I hadn't worked with Linux kernel development before, but through this, I got an opportunity to work on it. And we worked on PDM V1 implementation. We have a working implementation as of now. And the most important part, of course, I got to participate in IETF, present this work at IIESoc and the side meetings. So my experience has been really great so far, and I'm excited to know what will happen next. For the newcomers, I would like to say that I was not sure how this will turn out, how things go about, but turns out it's not very difficult. If I can do it, then of course you guys can do it. And I would like to conclude with it. Thank you. I think Abhishek can go ahead now.
All right. So unlike Ameya, I joined a few months ago when we were close to publishing the first version of PDMV2. And the experience has been very great so far. So the thing about any such project is that there is this huge gap between what you know in college or what you've been usually working on and the project, right? So nobody tells you how to develop something for Linux kernel. But once you do it, there is an immense satisfaction. This is something that you have done. So the experience has been great. I'm pretty excited to work on interacting with Nalini, Tommaso, Adnan has been great. Right? They're always very helpful. So I usually have some doubts. I call Ameya. Then we clear up our doubts. Maybe not then Nalini. So the experience has been very great. Everyone has been super helpful.
Great. Thanks so much, guys. So let me stop sharing, and I'm going to turn this back to Drew and see if there's any questions or how you want to proceed.
Yep, guys, please feel free to ask questions. This is now the open Q&A part. Don't be shy. Nalini and the team, would you like to share how was the experience like in the slide meeting? What was the feedback that you guys got in the presentation in IPPM as well as in the side meeting? What are the major changes that you have done so far?
Yeah, no, I thought that was very good. There were a lot of people at the side meeting, which was really great. And then in fact, there's a guy from an enterprise that we know from, that Michael and I know from before, and he will be joining our team also, and so that was great. And then we had some very interesting people. I know some who are very, very good at crypto from the IETF, and they only had one small comment to make, which, because that was very, very good to hear, because then you're always afraid, because one of the best things about the IETF is that if there's a problem to be found, probably somebody in the room will point it out. And so you're always nervous when you present, is because you think you've thought of everything, you've talked about everything, and then somebody comes in and then tells you something you've never thought of, which is of course the best thing about the IETF. Having said that, we had to do some rework, but it was minor rework as far as that, and so I was really glad about that. Presentation in IPPM, I think, was very good also. What we want to do, I think, we will actually, I think, discover problems when we implement, when we actually start doing things. I think we ourselves will see. And then I think people I think are watching. And so that's what we'll do, is we'll go through and present, as we go forward, and say, we've done this part, we've done this part. Because we haven't defined, what actually the flow is of this protocol. Anybody else want to say anything about the side meeting, about your experience and what you thought? And
I'll just say I'll just say that the side meeting was great. We had wonderful turnout and some incredibly intelligent folks that asked some great questions. And in many cases, they cited issues and situations that we're already addressing. So that's great. That's the synergy we want, and that's the way it's supposed to work. And now we're just progressing along the lines of making progress and making this real, doing the translation from theory to reality, which Amay and Abhishek, you guys are, your talk was just very inspiring, as Drew said, and you're the ones that are making that translation for us from theory to reality. And as people like Nalini and I often say, as soon as we see this on the wire, as soon as we see this in a packet trace, then it's real, and you guys are getting us there. So thanks to everybody for all your contributions and questions and help along the way.
Are there any plans for hackathon and stuff as well? Like, since we have some code that we are working on, would we be able to reach that stage?
Yeah, okay, so this is just my viewpoint again, and everybody else give their viewpoints. Okay, so I have a small software company. We sell products for sale. We sell commercial products, and so I have a little problem with hackathon. I'm not going to release code that I did or somebody did in a hackathon. It's not what I'm doing. And so it's like I prefer professional development. That's just my point of view. There may be some things that you can do in a hackathon. It's just, we'll have discussion. I don't mean to put down hackathons, but you guys know what I'm saying? It's like that's, I have no idea what the level of that code is and how good it is. And this way we can completely look at everything, think quietly about what decisions we make. Am I being too mean, Drew?
No, actually, IETF Hackathon can allow you to, make your own team. Maybe we are looking for inviting new people, and also it doesn't have to be that everything needs to be completely public domain. Then only it can be a part of IETF Hackathon, especially in the virtual environment these days. So I think that's not the case at all. So maybe there might be a little misconception where everything needs to be open. So I think it could be just a way for inviting set of people and only share things within that set of people. You don't have to make everything open.
Well, no. It can be open source. It can be open source. No, I see what you're saying. It can, because definitely everything we'll do will be open source, but we will do the original development. But I see what you mean. If somebody else, if someone wants to see what Ameya Abhishek have done, and then, yeah, I think that's actually a wonderful idea. That's wonderful. We can say, this is how we did, and this is our implementation. This is the protocol between here and there. But I think what we want to do is we want to, and again, guys, you know, team, you know, tell me what you guys think too. Because I think we're not quite ready for that yet. I think we want to we haven't quite defined a few things. Guys, what do you think? Ameya, Abhishek, Tommaso, Adnan, anybody, what do you guys think?
Yeah, I think we are in the process of figuring it out. And I think by the next IETF, we can focus on a proof of concept implementation. And yeah, so we can try for that. And we have, I mean, it's not like we don't have any ideas, of course, we have the ideas, and we are figuring out which is the best one for PDM, which one will give us accurate accurate details, and which one is feasible for users to test out. Then we can do a lot of testing. I think initially we had a user space idea as well, but now we have turned to kernel implementation because that's the one where we can have more accurate results. And since we have PDM1 in kernel, it should be easy to take it from there to PDMV2. So
this was just at a very high level, just something where I thought, like, would be the natural next step where you guys from the universities can get more people to participate. And that can also be a good entry point of anybody looking for participation in IETF. So I was just thinking from the very, very high level, and you need to figure out in your project what makes most sense. And since I'm not seeing any more questions, I think any last words from the team? Otherwise, we can close the meetup.
Yeah, guys, Tommaso, Adnan, do you guys have any final words?
Yeah, you say that encryption is the core of PDM, but I beg to disagree. The key part of PDMV2 is actual implementation. And I praise the fact that we will have a proof of concept. I want to stress that even though encryption is, in my opinion, one of the most important features of PDM to have it used on the open internet. Otherwise, it would be confined into closed, well-controlled parts, so diminishing greatly its flexibility and its availability. But implementation is the key. I think that the next steps are to prove that it can be implemented and it can have good performances even in small devices. So the Linux kernel implementation is, of course, a first step, but I'm really looking forward for trying to implement it into low power systems. And that's our main goal, because the idea is to have it available, I wouldn't say everywhere, but where you need it. So, yeah, and from an academic point of view, we are used to work with papers. I am super happy to work with this team because it gives us the opportunity to remember that things not only to be published on a piece of paper or onto an RFC, but they must be feasibly implemented.
Yeah, I think this, yeah, go ahead.
No, I think I was just saying that these famous words. So let's wish you guys all the best. And I hope this becomes a great success story from this good collaboration between people. Yeah, go ahead, Nalini.
Yeah, no, that's thank you so much. Yes, I think that's the thing is and I really encourage others, to find collaborators and to look, because I think we do need people from all this. You need the theory, you need the actual scalable perspective, and then you need implementation. And so I think that's to me the best way to write a protocol. And I really encourage everybody, get involved, just get your feet wet. It takes a while, but why not start? Okay, yeah. Thanks very much, Drew, for the opportunity.
Thanks, everyone. Take care. Have a great weekend.
Thank you, everybody, for the opportunity and great meeting.
Thank you.
Thank you.